This is the triangle center video quiz. Points of concurrency. Let's see if you are ready. You should take this quiz over and over again until you can get 100% every time. What does the term center of gravity mean? The center of gravity is the point at which a solid shape would balance. Which point of concurrency is this? This is equidistant to the vertices, so this is going to be the circumcenter. Which point of concurrency is this? This one is equally distant to the sides of the triangle, so this is going to be the incenter. Which point of concurrency is the intersection of altitudes? Orthocenter. Which point of concurrency divides a segment into a big part and a small part where, you know, we got these formulas. The big part is twice as big as the small part. The big part is 2/3 of the whole thing. Centroid. That's the centroid. Which point of concurrency is the intersection of perpendicular bisectors? That is the circumcenter. Which point of concurrency is this? Okay, let me give you a hint. These are medians. See how it goes from a vertex to the midpoint of the opposite side? These are medians. So which point of concurrency is the intersection of medians? That is the centroid. Okay, which point of concurrency is the intersection of angle bisectors? That is the incenter. Which point of concurrency is shown here? Well, here's a hint. What are these things? All right, these are altitudes. See how they go from a vertex and then perpendicular? These are altitudes. So which point of concurrency is the intersection of altitudes? Orthocenter. Which point of concurrency is the intersection of medians? Again, that is the centroid. Which point of concurrency is this? Well, if you need a hint, let me point out that these are perpendicular bisectors. See how they're perpendicular and they're splitting the side in half? So these are perpendicular bisectors. So which point of concurrency is the intersection of perpendicular bisectors? That is the circumcenter. Which point of concurrency is the center of gravity? You remember that balancing point I was talking about? That's one of the special properties of the centroid, is the center of gravity. Okay, which point of concurrency is this? Notice that these are angle bisectors. All right, these are angle bisectors. They're splitting the angles in half. So which point of concurrency is angle bisectors? That would be the incenter. Which point of concurrency is equidistant from the vertices? Meaning equally distant to those corners. That is your circumcenter. Which point of concurrency is equidistant from the sides of the triangle? The incenter is equidistant to the sides. Okay, that is it for that part of the quiz. All right, let me quiz you again, but let me also show you and remind you how Quizlet works. So this is a flashcard set, and you can create your own as well if you get comfortable with it. But just go to Quizlet.com. That's Quizlet.com. If you search for Mr. Helpful, Not Hurtful, okay, just do a search when you get there for Mr. Helpful, Not Hurtful, and you will find all of my flashcard sets, including this one. When you first turn it on, both sides will be checked off. You want to uncheck that, and usually you want to go ahead and do the first term only. Okay, so now we can start the quiz. Circumcenter, definition. I'm looking for the intersection of what? And then if you click on the card, it shows you the answer. So circumcenter is the intersection of perpendicular bisectors. If you hit this arrow, you go to the next card. Incenter, definition, meaning the intersection of what? Intersection of angle bisectors. All right, that's your incenter. Centroid, definition. So that's the intersection of what? Intersection of medians would be the centroid. Okay, how about the orthocenter definition? That's the intersection of what? That's the intersection of altitudes, gives you your orthocenter. Okay, now let's talk special properties. Circumcenter special property. I'll give you a hint. It's equidistant from something. Is this the one that's equidistant from the sides, or is this the one that's equidistant from the vertices, the corners? The circumcenter is the one that is equidistant from the vertices, or the corners. Okay, what's the special property of the incenter? Yeah, this is the one that's equidistant from the sides. What is the special property of the centroid? If you think about it, there are actually two different special properties for the centroid. Okay, one of the special properties for the centroid is, this is the one that has all those little formulas where the centroid divides the median into a big piece and a small piece, where the big piece is twice as big as the small piece, and you know, the small piece, you can make those three equal pieces, blah, blah, blah. So the small piece is 1/3 of the whole thing, and the big piece is 2/3 of the whole thing. All of that, I'm calling that one special property of a centroid. Also, a centroid is the center of gravity. So that's another special property. Okay. Perpendicular bisector. What is it? What is a perpendicular bisector? And try to picture in your mind what it looks like. Well, it's sort of in the name. A perpendicular bisector forms a 90-degree angle, and it's going to cut the side in half. That's what bisector means. Notice that it does not have to hit a vertex. So here's a picture of a perpendicular bisector. All right, it's perpendicular and it's a bisector. Notice that it does not have to go through a vertex. Okay, what is an angle bisector? Well, if you know that bisect means to cut something in half, An angle bisector is a segment that just splits an angle in half, like this. It divides an angle into two congruent angles. That's an angle bisector. What is a median? All right, a median is a segment that goes from the vertex and then ends at a midpoint of the opposite side. So vertex to a midpoint, that's a median. That's what a median is. All right, last but not least, what is an altitude? All right, an altitude looks like this. It starts at a vertex and it has to be perpendicular to the opposite side. Okay? Now, notice both an altitude and a perpendicular bisector, they're both perpendicular. So what's the difference between an altitude and a perpendicular bisector if they're both perpendicular? Well, here's the difference. An altitude, it has to hit a vertex, and it does not have to be at the midpoint. On the other hand, if I can flip back to my perpendicular bisector, a perpendicular bisector has to go through the midpoint, but it does not have to hit a vertex. So that's the difference. All right, that's the end of this quiz, this video quiz. I recommend quizzing yourself again later. Also, you can go to Quizlet and quiz yourself anytime you want.